Welcome to today's Explainer. We are about to take a wild, mind-bending journey into the hard, mathematically proven physics of our universe to explore something that sounds like pure science fiction, but is actually real-life time travel. So I want you to start by asking yourself, what if you could travel into the future without using a time machine? Seriously, think about that for a second. What if the fabric of the universe itself provided a natural mechanism for you to literally leap forward in time, leaving your current era completely behind? I know, it sounds like magic, but it's actually a cosmic mystery grounded entirely in physics. Could Einstein's theory of relativity allow a human being to experience less time than everyone else? The secret to all of this lies with Albert Einstein himself. Could you take a journey, feel like only a few years have passed for you, and then return to an Earth where decades or even centuries have flown by? Well, the math says absolutely yes. Part 1. What is time travel? The science of experiencing less time. Okay, let's dive right into this. To understand how this whole thing works, we kind of have to completely redefine what time travel actually means. Scientific time travel doesn't mean magically jumping from the year 2024 to the year 3000 in an instant. It's not a sci-fi portal. Instead, it means that different observers can experience entirely different amounts of elapsed time. It's all about the flow of time itself altering. A traveler can literally experience less time than the people who remain back on Earth. And when that traveler returns, they find that far more time has passed for the people they left behind. This whole concept stems from Einstein's two monumental rules of the universe. First up, we have special relativity. This tells us that the passage of time is affected by speed. The faster an object moves relative to another observer, the slower its clock runs relative to that observer. It's a phenomenon we call time dilation. Now, at everyday speeds, the effect is microscopic. You'd never notice it. But as you approach the speed of light, which is the universe's ultimate speed limit at a staggering 186,000 miles per second, the slowdown becomes massive. Second, we have general relativity, which tells us that gravity also warps time. A clock sitting deeper in a strong gravitational field is going to run more slowly relative to a clock further away from that gravity. So both speed and gravity literally change the ticking rate of reality itself. Section 2. The traveling twin paradox, a cosmic mystery. To really grasp how weird this gets, let's look at one of the most famous thought experiments in all of physics, the twin paradox. Imagine two identical twins. They're the exact same age, and their internal biological clocks are ticking at the exact same rate. Now, twin A remains at home on Earth. Twin B boards an ultra-fast spaceship and travels through deep space at a speed extremely close to the speed of light before turning around and coming home. Because of time dilation, twin B's clocks, and this includes their biological aging, run much, much slower compared to twin A. But here's the truly fascinating part. To twin B, their clock works totally normally, and their body ages normally according to their own experienced time. They don't feel slow, they feel entirely normal. But upon returning to Earth, they might find that, say, 30 years have passed for twin A. Twin B has effectively traveled into twin E's future. Now, you might be wondering, why is this called a paradox? And why isn't it just a two-way street? Because since motion is relative, couldn't the traveling twin just claim that Earth was moving away from them, and therefore the Earth twin should be the younger one? Well, no. The situation is not perfectly symmetrical. Step 1 is coasting away, but Step 2 requires the spaceship to decelerate, turn around in a tight curve, and then Step 3 is accelerating back toward Earth. During those phases of intense acceleration and deceleration, the traveling twin is no longer what physicists call an inertial observer. They are being pushed and pulled by intense g-forces. The twin back on Earth, they don't experience these extreme acceleration changes at all. That physical difference is exactly what locks in the time dilation, permanently making the traveling twin younger. Section 3. Proof in everyday life. Relativity around us. So you might be thinking this is just a fun math puzzle for a theoretical physicist, right? Actually, it's not. This isn't just theory. We have proven these mind-bending concepts over and over again right here on Earth. Scientists have relentlessly tested time dilation. We've literally put highly precise atomic clocks on commercial aircraft, flown them around the world, only to land and find they're slightly behind the exact same clocks that stayed on the ground. We measure it constantly with satellites up in orbit. And these aren't rounding errors or glitches. They are incredibly precise measurements that perfectly match Albert Einstein's mathematical predictions. Just to show you how personal this actually gets, researchers at the National Institute of Standards and Technology use these absolute state-of-the-art aluminum quantum logic clocks to measure relativity on a human scale. They found that if you simply stand 1 foot, just about 33 centimeters, higher on a staircase, you age faster. Why? Because you are slightly further from Earth's gravitational pull. They also proved that moving at just 20 miles per hour slows your time down. Now, before you start living in your basement and sprinting everywhere just to stay young, you should know the effect is tiny. Over a 79-year lifetime, standing 1 foot higher adds up to aging an extra 90 billionths of a second. But the fact that we can even measure it shows that the fabric of time is constantly fluxing around you based on exactly where you are and how fast you're moving. Now let's look at how this is built into the technology you use every single day. The GPS on your phone relies on a network of satellites orbiting the Earth, and they all carry their own atomic clocks. These satellites are moving very fast, which, according to special relativity, slows their clocks down. However, they are also pretty far away from Earth's surface, meaning they experience less gravity, and according to general relativity, this weaker gravity actually speeds their clocks up. So you have this cosmic tug of war. Scientists have to mathematically calculate the net effect of these opposing relativistic forces just to correct the satellite clocks. If they didn't have Einstein's equations built directly into the system, those GPS clocks would desynchronize from Earth fast, and your phone's mapping app would literally guide you miles out of your way in a single day. GPS isn't a time machine, obviously, but it is absolute, undeniable proof that relativistic time differences are physically real. Section 4. Can we do it? The limits of technology. So this brings us to the ultimate question. If the physics are totally sound, could we actually build a spaceship, travel near the speed of light, and leap hundreds of years into Earth's future? Well, the short answer is physics allows it, but our current engineering absolutely cannot do it. There is a massive gulf between what is physically allowed by relativity and what is currently achievable by human technology. To push a massive object, like a spaceship carrying humans, to anywhere near the speed of light would require just an incomprehensible amount of energy. And even if we could generate that energy, we'd have to protect fragile human bodies from the extreme g-forces of acceleration and somehow shield them from tiny specks of space debris that would hit the ship at near light speed. These are hurdles that our current science just cannot solve. We are bound by the technological limitations of modern spacecraft, which right now travel at just a tiny, tiny fraction of a percent of the speed of light. But all this talk of stepping forward in time naturally leads to one final burning question. If we can manipulate time to leap into the future, does that mean we can put the engine in reverse and travel into the past? The answer, based on literally everything we know and have demonstrated, is no. Relativity is strictly a one-way ticket. The time dilation effects we've discussed today provide a proven method for a traveler to experience less elapsed time, allowing them to arrive in the future. But there is absolutely no demonstrated method, not in Einstein's equations and not in our physical experiments, for traveling backward. The past is forever locked away. You are already a time traveler, moving into the future second by second. Physics tells us we could one day speed up that journey, but it leaves us with a profound question to end on. If the future is the only place we can ever go, how far ahead are you willing to leap, knowing you can never, ever come home?